finding extrema on a closed interval. So remember, extrema, that means our extreme values, our absolute max and min values. On a closed interval is important because remember the extreme value theorem? The extreme value theorem tells us that a continuous function on a closed interval must have maxes and mins. So these maxes and mins must exist according to the extreme value theorem. We cannot have a function that's continuous on a closed interval and not have absolute extreme values. Remember that maxes and mins can occur at critical numbers and at endpoints, like we saw earlier in the graph. So if we're not looking at a graph, but rather we're given a function, how do we find these extreme values? Well, remember we just learned how to find critical numbers, and we're given the endpoints of the closed intervals, and the max and min just means the lowest and the highest of the y values. We can find all those things without using a graph. Step one, we've got to find the critical numbers, since these maxes and mins can occur at critical numbers. So we remind ourselves that critical numbers is where the derivative equals 0 or does not exist. So for these examples, when we have to find these absolute extrema, first thing we do is find the critical numbers. Take the derivative, 12x cubed minus 12x squared. Since critical numbers is where the derivative equals 0 or doesn't exist, I notice that this is a polynomial. There is no place where this polynomial doesn't exist, so I'll go straight ahead to equals 0. We can factor this, and we see two critical numbers, x equals 0 and x equals 1. Now we want to evaluate the function at the critical numbers and at the endpoints because that's where max and mins can occur, at critical numbers and endpoints. We can do this a number of ways. I like to make a table to keep it organized and see our results. So x and f of x. Where can our absolute extreme values occur? At our critical numbers, 0 and 1, and at our endpoints, -1 and 2. We plug these into the function because we want to determine the lowest and the highest of the y values, from the original function. Remember that f of x means y. Plugging in 0 into our original function makes 3 times 0 to the 4th minus 4 times 0 cubed, or 0. Plugging in 1 into the original function makes -1. Plugging in -1 into the original function makes 7, and plugging in 2 into the original function to find the y value makes 16. So, of all of these values, this is the lowest of the y value for our min. So -1 is the min. Where does it occur is the x value, at x equals 1. Then the highest value, that will be our max. 16 is the highest, so 16 is the max at x equals 2. And there we have it. Let's take a look at number 2 and see how this might be interesting as well. G of x equals 3 sine of 2x on the interval 0 to 5 pi over 4. We begin by finding critical numbers, and we do that by taking the derivative. We have to use the chain rule here. First, the derivative of the outside is cosine of 2x. times the derivative of the inside, 2. 2 times 3 makes 6. So 6 times cosine of 2x. There's no place where the cosine function's undefined, so we'll go ahead and just set it equal to 0 and work from there. Divide by 6, cosine of 2x equals 0, and cosine will equal 0 at the angles pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2, and we could go on and on. But the angle right now is 2x, so 2x equals these values. Solve for x for the critical numbers by dividing by 2, or we can say multiply by 1/2. So multiply these by 1/2, and we get the critical values: pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4, and so on and so forth. However, we're just looking on the domain that's restricted, 0 to 5 pi over 4. So this one and any that follow is not a critical number. Now we need to find out the highest and lowest values of the function, the y values. So we remember g of x means y. Let's set up our table, x and g of x. Where can we get absolute maxes and mins? At critical numbers. We have 3 of them this time: pi over 4, 3 pi over 4, 5 pi over 4, and at endpoints, 0 and 5 pi over 4 I already listed because it was in the critical number list. Now let's evaluate the original function, 3 sine of 2x, at each of these values. 3 sine of 2 times pi over 4, 2 times pi over 4 makes pi over 2, so that makes 1, and 3 times 1 is 3. 3 times sine of 2, 3 pi over 4, and that makes negative 3. 3 times sine of 2 times 5 pi over 4, and that makes 3. And finally, 3 times sine of 2 times 0. Sine of 0 is 0, so that makes 0. Now we identify our lowest and highest function values. The lowest looks like negative 3. So the minimum is negative 3. Where is it? At x equals 3 pi over 4. How about the maximum? The maximum is, well, I see the highest value is 3. Of course, only one maximum, only one number can be the highest. Where it's located can be at multiple places. This maximum is located at pi over 4 and 5 pi over 4. And there we go. Number 3, also from an AP exam. The absolute maximum value of f of x equals x cubed minus 3x squared plus 12 on the interval negative 2 to 4 is, so if I know I need an absolute max, let's go through our steps. Find critical numbers. How do we do that? Find the derivative. What is f prime of x? 3x squared minus 6x. We find where the derivative equals 0 or doesn't exist. Nowhere this doesn't exist because it's a polynomial. Where does it equal 0? Well, let's factor. Looks like it equals 0 at 2 places, 0 and 2. Let's make our table to keep ourselves organized, x and f of x. Let's list our critical numbers, 0 and 2. Let's list our endpoints, negative 2 and 4. Remember, maximums can occur at critical numbers or at endpoints. Now let's plug it in to find the highest and lowest y value. 0 plugged into the original function, 0 cubed minus 3 times 0 squared plus 12, that makes 12. 2 plugged into the original function makes 8. Negative 2 plugged in makes negative 8. And 4 plugged in makes 28. So notice they only asked for the absolute maximum value, just the maximum. And that value will be the y value that is the largest of these. Here it is, 28. Thanks for watching. See you in class.